All right, let's continue. So we talk about the previous assignments. Most of them are group assignments, and this assignment is also a group assignment. This is how to use a BIM to finish estimating. We're going to use something called Assemble System. It's not a program. It's just a web browser-based app. So it's based on web. You just go to this web address, that's my last name, .tryassemble.com, and you just create a project. So this is from last year. You go there, and then you, of course, we're going to add a plugin in Revit. So basically very simple. You just basically publish a model from Revit, and you go back to your program. You'll be able to see the model, and just go there, open the model, and it lists all the information you need, such as the quantity units. And we will add, in a place, we will add a unit price. And this one will basically give us this amazing thing. Let me show you. I just go export the Excel spreadsheet. Open this. Guess what happened? That's an estimate with different levels. That's actually really well organized, professional look estimate. So think about how easy the estimating will be in the future. All right. So this is the 5D, and there are a lot of amazing function of this one. So this is a building here. Let me use this one. Boom. We can explore that and see all the details of this building. I can also cut it somewhere. Let me go closer. Here it is. Okay, hold on. Maybe like this way. I just drag it. You see this sectional view of that? Some other cool stuffs like, let me open this one again, and let me use different filter. Let's say categories. All right, and let me highlight this one, use X-ray, move it here, close to close, and I'm going to use this goes to view, X-ray view. All right, so now I say, hey, I don't care about, I'm a ceiling subcontractor. Can you show me all the ceilings? Here you are, that's all the ceilings. Okay, and I'm a door subcontractor. Can you show me all the doors? Here you are. That's all the doors in the building. Oops. Very convenient, very easy to use program. And by the way, guys, since it's a web browser, which means you can open this one on your iPad or phone. This is something called SaaS, using web browser to achieve a lot of functions. This will be something you guys are learning. Let me go back, leave. And of course here, cancel, it should be here, and that's different. Oh, here, edit project. Of course, you can select cover for your project. Let me open this data tree. And this one shows, you can put the unit cost here. You can just basically put the unit cost in Excel spreadsheet and upload it here. And then you can easily run that. And by the way, guys, if the owner wants to make a change, this is what will happen in the world of Revit. So let's say the owner say, hey, I don't like this this kind of wall. I want to select this one. I want to change it to, I don't know, like a masonry. All right, so now it's masonry. I know that will change my cost. Okay, so I go here, publish to my assemble. I come back here, open the model, assuming I'm opening that model, and just go estimate. Then it will basically give me the new cost and also show me the changes. I think this team uploaded 2 versions, so let me show the changes. So let's say between version 6 and version 5, it's the same model, so there's nothing different. Let me see version 1, update. Okay, so it basically shows, between 2 versions, what are changing. And I can visualize that. I also can show you the change to the cost. So that's actually the beauty of building information modeling. Everything is so intuitive. Everything is so human. Hey, I see you guys are sometimes frozen. Can you guys hear me clearly?
Yes, we can now.
Okay, great. All right, so I think you guys are going to love this tool. It's so convenient. And by the way, I know the guy from Assemble, so they gave me this permanent account. And so if you see this, let me go to not create pro. So this one's blocking. That's why. You see all the names? Those are all the students from last year. So I didn't remove their names. So literally speaking, they can still use this program. And do you guys know how much it costs for you to purchase a seat? It's $1,000 per month per seat using this very convenient tool. But since you are, taking this course, you'll be okay to use it. And I think I will leave your account for at least a year, so you get some opportunity to practice and to see the benefits of using this online tool. All right, so that will be the assignment 5, and there's no presentation, but I will basically go to your project and I will check if you finished up all the codes. If I generate a report, will it give me the correct report? So that's basically what I'm going to check with your team. I will just go to your job site, all right? So this is the assignment 5. And the final project, it's more kind of like a final presentation. So you guys are going to form a BIM consulting company and present a life cycle solution to transform your management with BIM from the programming, the design, the engineering, the construction, bidding process, to the construction coordination, all the way to facility management, how BIM can benefit things. That will be the final presentation. 30 minutes on December the 15th. And for graduate students, there will be another additional assignment. It's a BIM research paper, 3,000 words, and write a research paper on BIM related topics. Examples can include, but not limited to, challenge and opportunities of BIM, BIM applications in the AEC industry, data issues in BIM, BIM for facility management, BIM and mixed reality, such as virtual reality, augmented reality, BIM and artificial intelligence, okay? Some topics like that, and follow the technical writing. So it's more like writing a small paper, introduction, problem statement, your objectives, the literature review, summary, and discussion. That's also due on December the 15th. That's all the homework. Any question, any comments? All right, so I'm going to skip, this will be the tools we are learning for the semester. So Revit, Autodesk, Recap Pro, Autodesk 360, Assemble System, Mushroom, Luminant, Modelo, and this is Augment. But because given this year's situation, I don't think we can cover everything. So, but we will definitely learn this. Revit, Navisworks, Recap Pro, Assemble. And I will basically live stream and show you how to use Mushroom, Luminant, Modelo, and Augment. So it's more kind of like a lecture. All right. So, but this one and this one, two of them actually are probably already cover 80% of the BIM functions, for the industry. And this is actually increasing so fast. And this will be very promising. Assemble, the web browser based tool I showed to you guys. All right, so let me close this one, save, and let me show you the topic that I was planning to do next week. But now since we shuffle the schedule, so let's do that. Now I think everybody's muted. Can anybody do me a favor, unmute yourself, make some noise, so I know you guys are live.
Ooh.
All right, thank you. Yeah. All right, so we know BIM is useful and is popular, but there's a reason for that. And actually the industry, the AEC industry, has been struggling for more than 200 years. How to improve the productivity, how to improve the way we manage a project, how to make better designs, how to engage engineers better. I really want to share the history of BIM, because that can help you understand why we are here, and also can help you project what will happen in the future. And you also will see all the development. There's a reason, because there's a need for that, and the need comes from the deficits, the drawbacks of our industry. So when is the beginning of BIM? Arguably the beginning of BIM, people consider these two milestones. One milestone is in year 2002. Autodesk published a red paper called the Building Information Modeling. This is the first time that the industry started to use the term Building Information Modeling, BIM. But I don't think Autodesk invented the term, because I did see a paper published in 1992 also used the word Building Information Modeling. But anyway, money talks, because Autodesk is the main player. So we consider the first time used the term Building Information Modeling. And this is from the industry side. But from the academia researcher side, we consider this paper published in 1974 by retired professor Chuck Eastman from Georgia Tech as the father of BIM. He published this paper and used the word called a building description system. He described a hypothetical system that has all the information we need for a project: engineering information, the properties of a concrete, cost information, time information, supplier information, facility management information, everything stored in the same place, showing as a 3D model, object-based. So it's the first time that people believe that somebody systematically described the feature of building information modeling. So even though he didn't use the word BIM, but we consider this paper Building Description System, BDS, it's actually the first time somebody start to invent this idea of BIM. The problem with our industry is actually communication. This is a story shared by my friend. He was international student, so he basically bought, like every international student here, we were pool students, so we just bought really cheap cars, and we are always running mechanical issues of the car. So his car got some problem. He sent it to the body shop, and the guy said, "Okay, you need to change your timing belt." So my friend told me that I know what timing means, I know what the belt means, but when they put them together, I don't know what that means. What is timing belt? And giving the direction the technician was pointing, he saw it would be the brake. So he went back home and get the manual. This is what you see. When you buy a new car, you see this manual, right? So this is kind of like a very thick book showing that. So he basically did a whole day research and finally found, oh, the timing belt is actually the belt that moving, right? The engine, right? But nowadays we have this 3D model in some luxury cars, and there's a search engine. You basically search the keyword timing belt, boom. It shows where it is and it shows the functions of that and shows very clear 3D picture of that. Do you guys see the difference between this original way to store and present information and this new way to do the information? You guys see that difference? You guys can feel the difference? In fact, the problem of our industry is always getting on the same page. Architects don't understand what an engineer is meaning. And architect doesn't understand what the owner is meaning. And sometimes, the engineers don't understand what the owner is meaning. It's kind of like we don't understand each other. We are not speaking the same language. We are not on the same page. So there's a long-lasting and a profound question in the AEC industry: how to make communications much easier. When I say something ABC, you know what that means. How to make it easier. The source of the problem, the deep cause of the problem is something called a fragmentation. Unlike manufacturing industry, we have something called a vertical integration, which means what, guys? The supply, the production, and the marketing, the sales are all integrated as one business unit. Like think about that for Ford, when they're trying to build a car, they actually have a really tight supply chain that sometimes it's just their own, child companies, right? So they actually integrate that very well. You can consider them as a single entity and a single workflow. Unfortunately, construction or AEC industry is not doing that. Designers, owners, general contractors, subcontractors, facility management, and all the suppliers, they are still separate business. And they are tied because there's a contract. But when the contract is over, what happened? They are dismissed. They waive each other and they start to form another temporary relationship with other companies. Make sense? So because of that, it's very difficult for us to build a long-term relationship, a trustworthy relationship. And because we have to share information and we have so many parties, it's kind of like a mess here, right? So the information is sharing across different parties. And there's a wall, invisible wall. That wall is actually what we discussed, the liability concerns. I don't want to share everything with you, right? Because there could be some potential errors. I don't want you to see that because we don't belong to the same company and we have very different goals. So they usually hide a lot of things. And when a designer finishes the design, what happened? They just basically walk away. They say, hey, I finished my contractual obligations and my job is done. And the same thing for general contractor, when they are done, say, hey, my job is done. Because of that, the data in our industry looks like this. So what is our ultimate goal? Number one, we want to sort the data, right? So engineering data should come together, design data should come together, and also, like a cost data should come together, scheduling data should come together. So we want to sort them, we want to arrange them. So for example, for cost data, I also want to see only the cost of all the concrete. I want to see all the cost of the CMU. I want to see all the cost of reinforcement. So I want to arrange them. And finally, I also want a beautiful view of that. Think about the assembled web browser, like a door subcontractor say, yeah, I see all the numbers, the counts of my door, but I also want to see where they are in this building. So now you see them. So the final thing is presented them visually. So our reality is here, but I really want to move to here. We need to sort the information, arrange the information, and present them in a neat way. In fact, the lack of communication or the data thing is actually the cause of a lot of problems we are seeing today. About 50% of the waste of a typical building is actually is considered as waste. So if you are building a $1 million construction project, about 50% can be considered as total waste because of the lack of communication. About 30% could be saved with improved communication, which means about 20% we cannot do anything. But yes, if we have better communication, if I talk with my designer, if the general contractor talks to every single subcontractor, if everybody likes everybody, then literally we could save 30% of a project cost. About 56% of project cost is put at risk by ineffective communications. And 1/3 of project failures are attributed to ineffective communication, such as lawsuit, reworks, unknown conditions. No condition is unknown, guys. There's only ineffective communications. So that is actually the fundamental problem in our industry. And this roadmap shows how hard our ancestors, the pillars in our, the pioneers in our industry have tried so hard to push the frontier of our AEC and to make our industry an interesting industry, a more productive industry, a safer industry, a more profitable industry. So I think we should appreciate the efforts of these people. So I want to share some interesting story happened before and how we move from the traditional, information to this new information, because fundamentally the evolution of AEC is information evolution. The beginning. So the beginning of our industry is a totally paper-based industry. I found these pictures online. This one shows the workshop studio at that time. These people were doing design. This is how it looked like before. And this one shows, can you tell me why these people were lying there and drawing things? Anybody? Come on, guys.
There was not enough space for everybody.
They are doing the one-to-one scale. You know, at that time,
yeah.
if they want to build things, they have to have the one-to-one scale. So that's how they do the drawing. That was about only 150 years ago. All right. Hey, John, can you do me a favor? Can you keep yourself unmuted?
Yeah, sure.
It's feeling better, you know, if you do that. Thank you. All right. So before the 1960s, design data was mainly exchanged via papers, you know, and I have to say it was since the very beginning. So this is actually one of the earliest designs we found by Da Vinci, that he plotted this domed building. We believe that was plotted in about 1487 to 1490. But think about that, you know, about 400 years after that, we were still using pretty much the same method in drawings. Of course, technology advanced, so they developed something to help the paper-based design. Like this thing is called a universal drafting machine, invented in 1867, and this person was using that to do this, you know, drawing thing. And I provided this link. Let me see if I can play it quickly. This is really long video, so like there, this is actually the universal drafting machine, how it looks like. It's just basically some fancy ruler and can tell you the angle to make everything line up easier for you to move the rulers easier. So that's the universal drafting machine. But it doesn't change the picture at all, right? This is still how we design things-based papers. Then in the 1960s, something happened. People want some tools that can help us to copy, share the design information in a consistent way. So I don't want to keep doing this kind of a paper drawing. We have different formats, very difficult to copy that. So the first person I want to mention is Douglas, and he was the inventor of mouse. You know, this mouse we are using today, he invented that. All he was thinking is, how can we make the communication between a human being and a computer much easier? And then this Evan Sutherland, while he was doing his PhD at MIT, he invented this computer sketchpad. It's actually the first touch screen that is using a pen to draw things. And by the way, he was also the person who invented the first modern VR system in 1968. And by the way, sorry, again, this was something he plotted on the screen. So I found this video, and let me just play that quickly. This is how, at that time, about 50 years ago, that how people were using keyboard and also the pen to draw lines on the screen. Think about that. This is a much better than the paper-based design, because it's very easy to correct. I think he was talking. It's very easy to correct the angle. It's very easy for you to copy paste. So later he also showed that he could copy the lines and paste them and also move them easily on the screen. So I think there's a place, like he mentioned, that I can easily move the lines. So this is better. And also it's because of that invention, like to interact with computers becomes possible. So in the 1970s, we start to the sudden emergence of a CAD, computer-aided design. It's all because of that computer sketchpad and the invention of mouse. And we start to see the 5 companies, Applicon, Computer Vision, Autodesk, Kalmar, and the Intergraph. Those were the main players at the time producing CAD programs and CAD solutions. Unfortunately, only 2 of them were still surviving today. 3 of them just run out of business. And at that time, when we say CAD, we were not just talking about software. It's actually a bundled solution of both hardware and software, something like this, something like this. And for example, this system is called this system is called a PTP7. So it was running on 60K RAM, 20 megabit disk, and support of 1 to 4 terminals. So we cannot imagine 16K, right? So, but at the time, 16K was amazing. So check the price, about $120,000 for a system like that. That was equivalent to $350,000 today. So that was the CAD system at that time. And that happened in 1969, PDP system. This is the CAM DMD CAD machine. Actually, it appeared in, I don't know what's that behind. It appeared in a movie called Brainstorming in 1983. You know, they used, this is a sci-fi movie, so they basically took this as like some sci-fi fancy stuff, but actually what it was just a CAD system. They used it in this movie. Let me see, I think I missed something. Oh, nothing, all right. And then in 1974, you know, Chuck Eastman, Professor Chuck Eastman, mentioned that, you know what, I know it's fancy to have the sketchpad to plot the lines, but I don't think that is fundamentally different than plotting a line on a piece of paper. We are just making it easier to change, easier to share, but we need more. So what he said in 1974 is, what we really need is a virtual building in a computer with object-based design and a relational database. What does that mean? Even though you could plot a 3D cube in CAD, but in the eyes of a computer, those are just lines, a bundle of lines. The computer wouldn't recognize that as a cube. So there's no way for you to save all the properties come with the cube, such as the volume, number of sides, and also the area size, total area size of cube tied to it. And also it's impossible for you to think about put the cube on top of a table. But if the computer can know, oh, this is a cube, this is a table, then the computer can understand the physics law and put the cube on the table. But in the world of CAD, the 2D CAD, computer only sees them as a whole bunch of lines. So it's impossible for us to do it. So in 1977, Chuck Eastman, so 1974, he published that paper talking about the building description system. And in 1977, he proposed this glide system and say, hey, this is something we need. Unfortunately, he was too advanced. You know, sometimes when you propose something that is ahead of the year, ahead of that time, people wouldn't buy it. And we didn't have enough computing power at that time to realize that. So unfortunately, even though his idea about 40 years ago, about 50 years ago was exactly what we need today, it's exactly what we are doing today, but people forgot it immediately, and his idea just faded away immediately. Then what happened? People keep doing CAD, the 2D drawings, the whole bunch of lines to show the geometry of that. But because of the personal computer emergence in 1980s, we start to see the great success of CAD. You know, originally the CAD looks like, sorry, I think I just, looks like this thing, right? Very expensive, but then because of the emergence of personal computer, we can run a CAD on any personal computer. So instead of selling you both the hardware and the software, we just sell you the software. So that's why we start to see the boost of CAD market in the 1980s. You know, famous thing about AutoCAD, the first AutoCAD version, AutoCAD 1.0 was released in 1980. MicroStation and ArchiCAD, all invented and announced around that time. So this video shows AutoCAD 1.0 running on a PC. This video was shot in 1982 at MIT. Now this looks like the layout of today's CAD program. Of course, you also have the analytical functions inside here. Like if you put some numbers here, it generates the shapes for you and also calculates the area size, coverage, everything automatically. So everything is based on calculation. All right. So that's actually the CAD. In 1985, finally, Autodesk realized that, okay, we don't like 2D because that's how we human beings perceive the world. We perceive the world as 3D. So why don't we do 3D CAD? Let's have the dimension Z. And so that's actually AutoCAD 2.1. They added 3D CAD function that you basically plot lines and you define the depths. So it basically will generate this 3D model for you. But please note, that's not real 3D. It's still layers, bundles of lines to create the delusion of 3D modeling. Got my point? So for example, here you see this desk. It looks like 3 decks, but in the eyes of the computer, it's just this line, this line, this line, plus this line, this line, this line to create that. So it's not a table to the computer, okay? But at least we are moving a little bit toward 3D. So this is another video showing the 3D, the 2.1 3D function in 1985. I think there's also some. Let me fast forward to see, yeah, like this. So basically it gives you, it makes it very, see, you basically put it a level, and so it becomes a plane, and it's easier for you to add another dimension, but it's still just a whole bunch of lines. How many of you took a CAD class? Can you raise your hand? Most of you, or you can use the reaction button, you know, in Zoom. Yeah.
I did, yeah.
Yeah. So that looks very familiar, right? I don't think CAD changes a lot, right? Okay, so that's the 3D CAD in 1985. In 1989, some smart people, smart programs actually discovered that we need a real 3D, not just the fake 3D. So this is in 1989, and we're talking about 2 programs. One is called ArchiCAD, the other one is called Pro Engineering. Those are object-based programming, or object-based design. What does that mean? It means that I define, for example, I'm building a model of a table. I define the dimensions, everything, like you are doing in CAD. But once the computer generates that model, it has content, it has mass. It's not just the lines to show the boundary of a table, but it has a table itself. Make sense? So in the eyes of the computer for the first time understood that, oh, this is a table. The table has weight. The table is made of wood. So then it's possible for us to save material information, density information, color information, everything to that thing. And that thing we call it object. So this is actually the first time we have this object-based design in 1989. However, once again, they were too advanced. The timing was not right. So limited by the computer technologies, they were not successful, okay? So by 1997, about 80 years after the first version of ArchiCAD, they only sold about 40,000 copies. But AutoCAD, the 2D thing, by 1994 already sold 1 million copies, okay? So CAD, at that time, CAD was only a fancy way to plot things on computer screen, the lines, data integration issues remain there. No data tied to CAD at that time, all right? And by the way, ArchiCAD was running on Apple, not running on Windows. And there's a story behind that. I'm going to share the story with you. If ArchiCAD was running on Windows, the BIM world today would be totally different. All right, so history is so interesting. So this is a documentary talking about the ArchiCAD story. Gabor. He was the programmer and the founder of ArchiCAD. So let me see if I can find some old. Yeah, this is the guy. Here it is. That's when they, it's the Graphisoft, the company, and that's when they started their first ArchiCAD programming. And let me remind you again, ArchiCAD is actually very close to the BIM idea we are using today. It's object-based design, and they give you the opportunity to store all the information in the objects. And this is how it looks like, the programs look like. Yes, so it's totally Apple-based. Okay, and once again, I'm not going to play all the documentary, but there's the link. And if you're interested, you can watch it yourself. And I recommend, I know a lot of times you probably wouldn't watch it, but I really recommend you guys to finish the documentary. I actually, I really respect these people. I think these people are the guys that changing the industry, are pushing the boundary. Okay, so finally we're having the the turning point. We are finally moving from this 2D or delusional 3D CAD world to a real object-based design in 1993. Do you know why? Because the Pentium CPU. So the CPU was much better, was much faster, and this is called a Pentium 486. And I remember the first computer I was using is a Pentium 586. It was just different numbers for the CPU, but that was how it looks like. This thing is probably only, like our current, today's CPU is probably like 100 million times faster than the Pentium CPU. But at that time, that was a breakthrough. And it made it possible to move from 2D CAD to a real object-based design. So because of that Pentium CPU, only about 2 years after that, technology advances also led to changes. Only about 2 years after that, we had this SolidWorks. So SolidWorks was a great success. It basically followed the object-based design. It created real 3D objects. So in the eyes of computer, they know this is a chunk of things. This is a mass of things. This is a cube. And the reason it was successful is because of price. They run on Windows. Objects contain information. 3D objects are real mass, not just lines to show the dilution of 3D. And they sold it for only about $4,000. $4,000 was very expensive, but pro engineering was about 500% more expensive than SolidWorks. And the pro engineering was running on Unix. But when Windows became so popular, 1995 was the time when Windows became so popular. I don't know if you guys know the first popular Windows operation is called Windows 95. You guys heard about that? Oh my goodness, you guys are young. So I actually got, I saw some great. So actually my first computer that my parents bought for me, I think that was in, I forgot, it's 1998. So 1998, like I mentioned, the first computer I was using was running Windows 95. So think about that. This SolidWorks picked the right operation system that they didn't know. They probably didn't know that Windows will become popular in the future, but they picked that. And the other program, the Pro engineer, they picked the Unix. So that will basically make very different futures for the two companies. So that's 1995, and this is how SolidWorks looked like. That was a version 1. This is, guys, see the start button? This is so familiar to me. That actually is a Windows 95. That's how it looks like. When I was around your age, okay? Now you know how old I am. So here basically define the parameters, define orientation. I don't know if we can go there. And do things. And by the way, this is actually very similar to Revit thing. You know, you just basically define things and boom, you know, you are doing 2D, but actually will transfer to 3D. You know, like in next moment, it basically shows that now I basically see that from the 3D view, now it becomes 3D, all right? And also become an object, not just 3D, not just lines, but a mass. See, it's a mass. Another way to see if this is a mass or just lines is when you use your mouse to select this cube. If you put your mouse in the middle, it still selects it. That is actually a mass, a cube, right? But if you have to go to the line to select it, is that those are just a whole bunch of lines. Make sense, guys? So that's a SolidWorks, 1995. Okay, so in the 1990s, another thing just emerged, raised, internet. So things such as FTP, HTTP, email, and OA, office automation start to emerge. How many of you have used FTP ever? No? Once again, you guys are young. So I actually used FTP, you know, at that time, if I want to, you can imagine this is more kind of like the old version of a Google Drive. Like if I want to upload something, it's not as easy as an open web browser and just drag the files here. You have to install some program on your personal computer, open, you know, the what do we call the Mac DOS system, and type a lot of lines and get the server address, and then you basically see the bar chart showing that it's uploading to something called FTP server. And then you go to another place, you have to download, you have to code again, and to download the thing from the FTP server. That's called FTP. But it provides a way to do what? Sharing information. So think about that. Before the emergence of internet, even though you have a CAD model, or you have a SolidWorks model, the real 3D model, or the 2D models, how would you share it with others? The soft disk, you know, what do we call a 3-inch or 5-inch soft disk? You guys learn, have any of you used that before? No? Oh my goodness. I'm gonna show you that. It's called a 3-inch disk. No, this one. Yeah, like this. Have you seen this before?
Yep.
Yeah.
Yes.
Yeah.
You know, when I was doing my college, it's my first year, like in my class, you know, we were required to buy 10 of these things, you know, to take the computer lab. Each of them can only store 1.44 megabit. And so there's something called A drive, you know, and by the way, guys, this is an interesting story. Do you know why we only got a C drive, but we don't have A drive or B drive? Because the A drive is for this guy, the B drive is for this guy, and the C drive is what we call the hard drive. And since these guys are gone, there's no A or B drive today. So at that time, we were using these things, you know, like we insert them in the B drive or A drive, and then the machine starts to make a funny noise, you know, so it's basically reading things. So if you have a CAD model, that's what we did. You insert that, you save it. Sometimes your model is bigger than 1.44. It will basically stop there and tell you, please insert a second one. So insert a second one, insert a third one. So when you try to send the model to somebody, you get an envelope, you put a 3/4 such a soft disk and mail it to them. That's actually before the era of internet. But in the 1990s, things were different. We started to have FTP. We started to have email, all right? So some companies start to think about, okay, we need to combine CAD with internet. And that's the rise of Bentley. Have you guys heard about Bentley? It's actually considered the #2 player of BIM today. So Bentley originally was just doing sharing CAD model. So they focused on CAD data sharing in 1996. They basically announced this teammate 96 to use the internet. And this is how, in 1996, another company, Walt, also developed some program that can help you share your design data, your CAD model with others, later acquired by Autodesk. But because this teammate was a little bit early. Timing was right for Bentley. So Bentley became a successful company today. All right, so we saw all the advanced, like we have CAD, we have internet can share data, we have the real 3D, the object-based design. Then the industry started to try it, to test it. So in 1993, the Heathrow Airport in UK was considered the first project that ever started to use CAD plus data-based project management. So let's not use papers. Let's use computer models and use internet to manage an entire project. So, but at that time, it's not like today that you just have one AutoCAD can do everything. At that time, we have a whole lot of different programs like Sonata, ArcCAD, CAD+. Okay, let me see. Declan. Can you guys hear me?
Yes.
Yeah, just a phone call just interrupted. And also for coordination, they use the Navisworks, Solibri. And also they hired a consulting company to build something called a CDE. The CDE is actually the common data environment. So this is, you can imagine the CDE is what I mentioned, the FTP server. It's actually an address you can use to store all your data there. And they also use this program called Maximal to manage their facility management. So far it looks great, but still it's not considered as BIM. So now we are approaching the late 1990s. We're almost BIM, but what was missing? This is something called parametric modeling. What I mean, SolidWorks, Pro Engineering, they can build real 3D models and tie information there, but the Pro Engineering model cannot read, the SolidWorks model. SolidWorks model cannot read the Pro Engineering model. And not that, if you build a cube and you tell the computer, this cube, not the cube, let's say, if you build if you build a table and tell the SolidWorks this is table, now if you change the dimension, it only change the appearance of that table, but it wouldn't change, like for example, the materials, the texture, anything tied to it. You have to be a smart programmer to change the fundamental meta code to change everything. This is something called parametric modeling, that you cannot change the parameters. You can only change the view of that. So that is the last thing missing for BIM. That's why we still didn't call them BIM. In fact, parametric modeling was born in the 1980s. Pro-E was using something to give you the script window that can type in scripts to change the parameters. If you don't think the material is correct for this piece, yes, you can change the material, but you have to program to change it. And this CATIA V4 in 1994 also using the parametric modeling. But once again, they were too advanced at the time. So this is Pro-E. I'm going to skip this one, but this is the first parameter modeling. So let me play that just quickly. This is the first parameter modeling program in 1987. And how you change the parameters. Select it. Let's see, where's that? Okay, cannot see the programming part. All right, so let's move that. So, and this parametric model, like I mentioned, was the last thing that missing for us to call it BIM. So in the late 1990s and early 2000s, we start to see the emergence of more parameter-based modeling. For example, Revit, Bentley, CATIA V5, Architect, and Pro-E all started to integrate that parametric modeling function in their program. And finally, in 2000, there's a program, Grasshopper. It's a graphic UI that if you want to change the parameter of something, you do not need to code things. You can just use the windows to drag some some boxes and connect the boxes to change the parameters. So it is not EDA proof, but it's much better than the original methods. So designers finally can perform parametric modeling, not just the programmers. So history is ready to make the last move. And this is how Grasshopper look like. This is actually today's version, not the first version. So this is the view of that. And then there's another window that, let me just fast forward to there. Yeah, there's another window that I can basically say, oh, this X means the depth of the building, Y means this. So let me connect this one. And I can input even formula to show the curve of the roof. And you can basically connect, the data, the output of some box will be the input of another box, so you can run the formula. For example, a case for parametric modeling is the number of chairs depends on the size of the room, right? So if you know the formula, then you just create the two boxes. One is the size of the room, the other one is the number of chairs, and you define the formula in the middle. Now, if you just, in your design, you just change the size of the room, you do not need to manually change the number of chairs, because this window, this interactive window will basically change the number of chairs automatically. Make sense, guys? Or if you want to change the material of something, it basically change the load of the building. If you define all the formulas and the parameters correctly, everything will basically change by themselves. That's parametric modeling. See, the parametric modeling window can become more and more complex depending on what you have. Finally, 2000, we're ready. Like I mentioned, the history was ready to make the last move, the birth of Revit. So there's also a story behind that. So in 1996, PTC, that's another CAD company, acquired a company called Reflex, and added a PTC was actually the company created a pro engineer. So they acquired a Reflex and hoping to increase their CAD market share, but only after 1 year, they gave up, because AutoCAD was so strong and they couldn't beat AutoCAD. So PTC totally gave up on the AEC industry and focused on mechanical design, like airplane design. So they sold Pro E. And because this Reflex was added to Pro E, so Reflex was also sold together. So the same time, Pro E, they quit PTC and started their own company called Charles River Software. I think it's in Boston. And their original plan was to continue their Pro E and Reflex project, and they all finally gave up. And about 3 years after that, they started their own new project called Revit. This is actually the first Revit, very similar to today. And they created this smart, brilliant editor called the Revit Family editor. What that is? So the original SolidWorks and all the 3D thing, you can imagine you have still to build, some objects and assign the name to it. So let's say I build some objects and say this is a table. I build another object, say this is a desk, and I build another thing, this is a bookshelf. But a Revit Family editor is actually very similar to Minecraft, right? You basically just say, this is a table, this is a desk. I'm going to drag it here, and I just change the parameters later. Make sense, guys? So the previous method is you put the parameter first and you assign a name to it. But now I can basically drag it and change the parameters later. Why this is better? Because you can scan over what you have. When you play a video game, it's kind of like you have a backpack, you have some things inside, if you collect all the things, you know what you have, you can scan over what you have, like this Revit thing. So I'm going to open this Revit. See, in architecture, I have walls, doors, windows. And it's just open walls, let's say I open windows. Save the project. I have a whole bunch of course, this is not a whole bunch of windows because I still haven't loaded all the windows here, but you just pick it from here. Like for example, for walls, you can pick the walls from here, whatever walls you want. For structure, same thing, that for beam, I can pick the beam from here. And I didn't load every beam, so that's why it looks funny. And also same thing, for slabs, I can pick the slabs here. So you are basically picking things. That's called a family editor. And it's so easy to prove that everybody loves that. That's why Revit, start to gain the momentum in the BIM market. All right, so we start to see the success of this new thing. We don't know how we call it, but we know this is object-based design. This is real 3D. We can tie a lot of information to it. There's a drop box that we can basically pick things we like, So it make the design so easy. We don't want to call it CAD anymore, because every time when we call something CAD, engineers tend to think it was another 2D modeling tool. Because AutoCAD was so successful, it totally changed the mentality of engineers. That was the bad thing. So we need a new name to describe the new object-based design and the parametric design to focus on data modeling, not just the geometry modeling. And we believe, and people at the time, the leaders at the time believe that the new name would lead to the mentality change and ultimately lead to a new market. So the company start to give their own suggestions, like names like a building modeling, virtual building, integrated project models, database building design, object design, all disappeared later. Okay, there's another story. And talking about why we have this BIM, we have to talk about this lady, Carol Bartz, a shopper from Autodesk. She served as a CEO for Autodesk for 14 years, from 1992 to 2006. We have a lot of female CEOs who really love buying companies. For example, Yahoo, right? So Yahoo bought a lot of companies, and Yahoo CEO was also a lady. HP, the former CEO, was a lady, was a female, and she also loved buying things. Same thing for Carol. She just loves shopping, and she bought a lot of companies. Here's just a couple of lists, like MES, Inshika Software, SoftBank. And then finally, in 2002, she bought Revit for $133 million. And that's the moment, February 21st, 2002. Why I mention this story? Because Autodesk at that time had their own BIM software called the ACA or ADT. It was not that successful, so they bought this Revit 1.0. But this Carol thinking, maybe I should put them in computation. So she didn't merge this one to this original ACA or Q this original ACE, but Autodesk was selling two BIM software packages at the same time at that time. So they were selling ACE and also Revit at the same time. And then we have to talk about this guy, the David Lemond. This guy, he was the original Revit CEO, and after Autodesk purchased, this Revit, he became the vice president and also the product manager for Revit. So he was competing with the ACA team. So there was a tension between the two teams. So that's very interesting. In 2000, before Revit was purchased by Autodesk, he said Revit will become a great addition to CAD. He said that. So Revit will become a great addition to CAD. But after Carol purchased this Revit in 2002 and told them, hey, ACA team and Revit team try to compete each other, he said, no. Revit is very different than CAD. Let's give it a new name. So during a client conference in May 2002, he just said this is historical momentum. He basically found a blackboard and say, hey, you guys, can you fill the blank here with the name of this disruptive CAD technology? And the guy put the name building information modeling there. And unfortunately, we don't know who the guy was. We forgot the name totally. But that was the moment a person wrote the 3 words on a blackboard. It's called a building information modeling in 2002. Right after that, because this David was a strong person and was a good salesman, he convinced Autodesk to publish a paper using the name he invented, building information modeling. Then this was the famous Autodesk white paper, building information modeling. So in this white paper, Autodesk described how CAD technology was moved from layer-based CAD to object-based CAD to parametric CAD, and finally, we call them building information modeling, all centered around Revit. And here they mentioned that building information modeling is Autodesk's strategy. So it became the focus of Autodesk. What happened to the ACA team? They didn't have good salesmen, so they were totally beat by this Revit team. And finally, Autodesk closed that team and laid off all the personnel, all the people from that ACA team. So that was the story. Now, we start to have this Revit, but why BIM became so popular? Now we have to talk another person, Jerry. Jerry was running something called social media at that time. At that time, we don't call it social media, we call it blog. Now you guys, have you guys heard about blog?
Yes.
Yes.
Finally, you guys know something that I know, okay? So blog is actually the social media at the time. So we are running some articles online to attract people to read your article. So Jerry was doing that, and he wrote a famous article comparing, sorry, that's two French words. I don't know how to pronounce them, but they means apples and orange, comparing apples and orange. So his was comparing BIM and CAD. He noticed that BIM was very different than CAD, and BIM could transform the industry. So he said this, so BIM as a description of the next generation of design software seems to me to come closer to the winning characteristics evidenced by CAD. So he noticed that this is different. And because of this success in this BIM term, Bentley, graphic software, Vectorworks all say, oh, you know what? We have done similar things, you know, it's nothing new, but we love this term. So they started to publish their own white papers in the year 2002 and 2003, used the same term, building information modeling. So this is actually the Bentley's paper in 2003. They start to use the same term, building information modeling. Think about that, guys. That's only about 17 years ago, right? So around the same time, Jerry actually ran this event at MIT. This is an open course at MIT. So he invited this senior VP that is managing Revit from Autodesk, Philip, and the case, Bentley, the founder of Bentley, to engage in this debate that what do we need for the AC industry, CAD or BIM? That is the question. So I basically had this debate, which we call today the Great Debate. So in that debate, they basically say the AEC industry needs a new concept to start over. They're not saying that we should improve CAD, we should improve AutoCAD. They say we need to start over, and that's building information modeling. And once again, I found this, guys, I spent a long time search for those old documentary. And so I would recommend you guys see this. But of course, I'm not going to see this one. It's boring, 2 hours, but it showed that at that time, you know, the leaders at that time, how they projected the future, how they projected what would happen in 20 years, which is now. Very interesting. And the link is here. Finally, because Autodesk, Bentley, graphics software, you know, all those companies start to come on the same page and start to use the same term, building information modeling. They start to notice it's time to have a common voice. So in 2005, they published this report, the business value of BIM. This is the first version. Remember I showed you the reading material? That was the, I don't know, the third version or the fourth version, but the first version was published in 2005. And in this report, the business value of BIM, they predicted that BIM represented a $10 billion market, all right? And once again, the link is here, the original version of this report in 2005. Okay, so now everybody's on the same page. The technology suppliers, you know, they notice that this will be a great market. What is the next step they are taking? Think about that. If you think you have a good product, what is the next step you want to do? Sell the product, right? So you want to sell it. And here's the knowledge. How to sell something in the AEC industry. Sell to whom? Anybody?
To the construction companies?
Many talks. Sell to the owner. Who pays the bill for a construction project? The owners. Yeah. These companies were smart. They actually hired a lobby company and tried to convince the biggest owner in the US. Who is the biggest owner in the US? US General Services Administration, GSA. So they have about it's $66 billion annual budget. They run more than 9,600 facilities, and every year GSA is building more than 200 new projects. They're the biggest owner. if you are Autodesk, if you are Bentley, you want to sell this new concept of BIM to general contractors. General contractors don't care. But if the owner say, hey, I want you guys to use BIM, then general contractors have to use BIM. Make sense? So they approached the decision maker at GSA, in 2003 during a conference. This is how history happened. I'm so excited, They basically hired some consultant and approached a guy from GSA and showed them BIM. And then the guy started to see, oh, why at this conference, everybody was talking about this thing called BIM. Every company was talking about this thing called BIM. So he started to do some research and pushed by the software companies. GSA actually published a report by the end of 2003, the same year, called the GSA's National 3D 4D BIM program. And this is the link of that program. And because GSA say, hey, BIM is a great thing, then very soon, Navy and the US Army Corps of Engineers, they followed up. They also say, okay, let's try BIM. So all the owners started to kick in. And then what happened? General contractors had to use BIM. That's when everybody started to buy Revit. That's how the story happened. In 2007, people start to notice that BIM is more than just design. BIM is used for design, but it can also potentially benefit construction by plan the job site, coordinate efforts of different subcontractors. It can also help the facility management. So Penn State University published this thing called PXP 1.0 in 2007 to talk about how BIM can be used, where BIM can be used. And this is actually a very famous model today. Now I think it's version 12 that how BIM can be used anywhere. So BIM, after that, 2007, BIM has become a promising IT solution to solve the profound and the long-lasting fragmentation issues in ADC industry. So similarly, the product, HOK network also proposes a concept called the BIM, BAM, BOM model. So the BIM is for design, BAM is for building assembly, which is the construction, and the BOM is for building operation, and to support the product lifecycle management. So after 2007, we know better BIM. BIM is more than a design program. BIM is actually an information management program for everything that you could have in a product. So after that, more companies start to see the opportunity, and not just the design company, but facility management company, construction company, contracting company, bidding software company, surveying company. They start to see the benefits. So they just, all of a sudden, all the companies start to enter this BIM market. So this map shows a whole lot of programs appeared at that time. Those are the interface at the time. We have too many data standards. What happened? We need a standard. Since we have so many data standards, so in 2007, software companies were fighting to promote their own BIM standards. They want to be the leader. So in 2006, GSA say enough, because we are dealing, on average, we are dealing 10 different programs and 10 different formats of BIM. We need a standard. And the US Army of Corps of Engineers found the same issue. So they started to design their own solution, but they used two different approaches. GSA actually hired an organization called Building Smart to design some standard called IFC, Industry Foundation Classes. It's the English for building science. So when I say this thing, people say this is desk, but people could also say this is table. So what the IFC is saying that let's call this desk forever. So we give it the same name. And when we say desk, we define the properties, and this is the list of properties we should define for a desk. That's called IFC. But the US ACE actually created their own standard called the COBE, Construction Operations Building Information Exchange. Have ever of you heard about the COBE? Nobody? All right. So those are two standards developed in parallel, but finally COBE was merged into this IFC. So in 2007, the first national BIM standard called NBIMS V1 was announced. It talks about IFC. It talks about all the technical aspects of building information modeling. And in 2012, this COBE standard, independently developed by the USACE, was finally merged into this national building information modeling standard. So now we have a common standard, which is called NBIMS. In 2007, the British were catching up. So right around the same time that the US published the NBIMS 1.0, US published something called the BS, British Standard 1192, focuses on, this BIM. At that time, they didn't call this BIM, they just call this collaborative production of architectural, engineering, and construction information. So unlike the NBIMS V1 that focused a lot on technology standards, this UK standard focused a lot on business applications, more how BIM can benefit the business. And in that standard, that's another milestone. They proposed something called BIM maturity levels. Actually, UK is saying that BIM should be advanced from BIM level 1 to level 2 to level 3. They also gave the description and standard that when we can call this company BIM level 1 company, when we call that company a BIM level 2 company. Make sense? So describe that if you're practicing the following things, then you are a BIM level 2 company, all the way to BIM level 3. And in 2007, UK took another aggressive leap. They legislate the BIM requirement. They say by the year, all companies have to be achieving BIM level 2 to receive a contract from the government in 2011. But what happened? Just about 3 years after that, it saved the UK $1.4 billion construction cost. And this number shows that in 2011, the cost to build 5 schools could build 7 schools in 2014, just after 3 years. They saved that much. So after that, this legislation thing affected a lot of followers, such as China. They start to focus on this top-down management of BIM development. So now it becomes an international computation. So Moroslow, he is a professor from University of Maryland. He said, nowadays, this BIM is not about the business. This is more about the politics and the leadership, and why the countries are trying so hard to push the BIM. The success of BIM, this is the last comment I have. We could have a totally different terms or totally different software than Revit. I think the success of what we have today is the right timing and the right place. I'll give you an example. The founder of this guy, the graphic software, he came from Hungary, and Hungary was used to belong to Soviet Union at that time. And because Apple computer was banned in Soviet Union, so this guy was so curious about using Apple computer. So he purchased smuggled Apple computers, and he used those things to program his object-based, BIM program, which is ArchiCAD. That's the story, guys. Why ArchiCAD didn't run on Windows? Because this guy was so interested in Apple computer. Why he was so interested in Apple computer? Because this guy couldn't buy Apple computer from his own country. So that's why, that's how the story leads to our current thing. And very interesting, the founder of Revit was also from the Soviet Union. So Lenoid, he actually moved to the US in the 1980s. That's actually the history. Now, let's check the timeline very quickly of BIM. 1968, computer sketchpad. Finally, we start to digitalize drawing. 1975, the first commercial CAD program, the BDS, also proposed by Chuck Eastman. 1980, AutoCAD 1.0 started to came out. 1985, the first AutoCAD 3D modeling. 1989, we had the earlier time of object-based CAD, like ArchiCAD, but it was not successful. And also we have early type of parametric modeling, like Pro Engineering, but it was not successful because they appeared too early. 1995, because of the advancement of a Pentium computer, Pentium CPU, we finally have successful object-based design, the SolidWorks. 1996, CAD+Inertent to share information. And we had this FC 1.0 at the time, but was not successful because once again, it was too early. Revit 1.0 was announced in 2000. BIM was finally ready. 2002, you know, we had a great debate in the industry, CAD or BIM, and the BIM term was won. And in 2003, we successfully convinced the owners, GSE, ACE, and the Navy. And finally, FC became a standard promoted by GSA. In 2005, the industry started to have a common voice on BIM. They say the business value of a BIM. 2007, we started to have the first standard, you know, NBMS 1.0, and also UK has the first standard, BS 1192. 2011, UK legislated BIM and called this government construction strategy. So they have 3 levels to achieve. And 2016 was the first time VR and AR started to be used together with BIM. And who knows how the future look like? What's next? We don't know. You know, maybe it's more about the virtuality. Maybe it's more about immersive applications. So we're running out of time. So we will basically leave this reflection, this discussion next time. But I really want to share my feeling with you guys. You know, history is actually a result of a lot of people's hard work. And also it's a result of a lot of random events, right timing, right place, right people. You guys will be making the history in the future. So I really hope, you know, something you learn in this course and the other course you learn at UF can be some life-changing moments that to make you think about the future of our industry. And maybe, who knows, maybe you will be the one that appear in somebody else, you know, PPT in the future and sharing your personal story with the future generation. All right. So next week, we're going to learn Revit. Make sure to solve all the Revit issues before next week. Let me know if you have issues. And meanwhile, you can also try to create a ticket. UFIT will also give you some guidance. All right. See you guys next week. Bye-bye.
Thank you.
Thank you, Dr. D.
Yeah.